Okay, let us start chapter 3. Special probability distribution. So in chapter 1 what we did, chapter 1 was probability. Okay, this is chapter 1. Now after that we split this probability into two variables. One is discrete and another one is continuous. Now this is we just finished this. This is chapter 2. This is chapter 1. Now we are going to go into chapter 3. In chapter 3 what will happen, we will see, okay, we will study two special probability in discrete, namely one is binomial, another one is Poisson. And in chapter in continuous we learn one distribution, probability distribution known as normal. Okay, this is chapter 3 which we are going to see today. Okay, you can see the continuation, the relation between chapter 1, 2 and 3. Okay, so first special probability falls under discrete. It is known as binomial, you can see here. Okay, discrete distribution. One of the special discrete distribution is binomial distribution. The name of the distribution is binomial. A binomial experiment consists of a fixed number of trials. Each trial has two possible outcomes, success and failure. We will go through this by one example. The probability of success is P, the probability of failure is Q. Q is 1 minus P, and the trial are independent, which means that the outcome of the trial does not affect the other one. Okay, so let us see one example. This is the formula for that. Okay, some of you have gone through this, some of you. Okay, you can see the formula here. And remember, in discrete we find the mean and variance. For binomial distribution there's a special formula for variance. You don't need to go through all this E, X, what do you call, you want to find EX the mean. You don't need to go through this thing. Each time you multiply with the probability and find the thing. No need. This one no need anymore. There's a special one. You just if you want to find the expected value or mean, n times P. N is the number of trials, P is the probability of success. And for variance, NPQ is the probability of failure. We will see one example, maybe you understand much more clearer. Okay, you read this example first. Pat is a student taking a statistic course. Unfortunately, Pat is not a good student. Pat does not read the textbook before class, does not do homework, and regularly misses the class. Pat intends to rely on luck to pass the next quiz. The quiz consists of 10 multiple choice questions. Each question has 5 possible answers. One way, only one of which is correct. Pat plans to guess the answers to each question. Okay. First of all, let us do one by one. For this to be a binomial distribution, you need to identify all these things. The characteristic here 1, 2, 3, at least 1, 2, 3. The fourth one you don't need to do anything. A binomial experiment consists of fixed number of trials. Look at this example. How many trials are there? The question consists of 10 multiple choice of questions. So Pat going to answer 10 multiple choice of questions. The n here, the trial is 10 here. He going to answer 10 times. Okay, 10 times he going to try for each question. Sorry, there's a 10 questions, so 10 questions she going to answer. Each question has 5 possible answers, only one of which is correct. So for her, before that, n is 10. Second one is what? Each trial has 2 possible outcomes, success and failure. Success here is answering correct, and failure here is incorrect. There are only 2 possible outcomes. One is correct and incorrect. That is binomial. Bi means 2. If you handle an event, the outcome should be only 2, either yes or no, or morning or night, something like that. Correct or incorrect, only 2 should have. P is the probability of correct, success, probability of success. What is P? Each question has 5 possible answers. All answer is 5, only one is correct. So the probability for her to answer correctly one question is 1/5. What is Q? Q is probability of her answer incorrect. Incorrect means 1 correct, 4 more incorrect. You can write, you can see like that. Or normally what we do, Q is 1 minus P. P and Q, you have it. What is the variable? What is the probability that Pat gets no correct and answer correct? What is the probability that Pat gets no answers correct? Which means X is number of correct answers. The notation for you to write this question in a binomial statement is X is binomial, whereby in 10 trial write the probability. This is N, this is P. Okay, this is a statement of binomial. Now once you write all these things, which means you have collect all the data, all the information. Now let us try to answer the question. A, probability that x equal to 0. Probability x equal to 0, x equal to 0 means number of correct answer is 0. That is the question A. What is the probability that Pat gets no answer correct? So x equal to 0. That is, total question is 10. No answer is correct. This is the formula I am using. Just here you write the P. What is your P? 1/5. Here you write the Q. This 0 will go here and 10 will go here, which means 0 question is 1/5. 0, no answer correct. What? No answer correct is 0. 10 answers are wrong. 4/5. That's how we have to see. If you plus these two, 0 plus 10, you should get back this answer, 10. Maybe first question you are still don't get my point. If you do this, you get this 0.3020. Sorry, this is 1074. B. What is the probability that Pat gets 2 answers correct? 2. Total question is 10. X is equal to 2 right here. How many answers, how many questions are correct? 2, isn't it? So 1/5, 2 here, 4/5, 8 here. Remember, if you plus this, 2 plus 8, you get back 10. If you do this, your answer should be 0.3020. Example continues. Find the probability that Pat fails the quiz. A mark is considered a failure if it is less than 50%. So you can put there C to answer this. Find the probability that Pat fails the quiz. When you will fail the quiz? See, all together you have 10 questions. When you will fail the quiz? When you cannot get 50%. Okay, a mark is considered failure if it is less than 50 percentage. Fail equal to less than 50 percentage. Less than 50 percentage means your correct answers is less than 5. Hope you understand. Out of 10, if your correct answers are less than 5, then you are fail. Equal to 5, you are on border, pass, because 50 percentage. 50 percentage out of 10 is how much? 50 percentage is equal to 5 questions. That's why I get 5 here. Less than 5, 50 percentage, it must be less than 5 questions, then you have failed. So for us to find your probability of failing is x must be, correct answer must be less than 5, then you have failed. You start with x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4. You cannot go x equal to 5 because there is no equal there. X equal to 0, if you do this in calculator, your answer should be 0.9672. Okay guys, I suppose you guys copied already. Now there's another one. Suppose that a professor has a full class full of students like PET. What is the mean mark and what is the standard deviation? So I'm going for next page now. Okay, I suppose everybody has copied. If I'm going fast, let me know. I write this as D. They want mean mark. Mean is, we know that is NP. Our N here is 10. Our P here is 1/5. So the answer is 2. Variance NPQ. This is quite easy. 10 1/5 4/5 1/6, and the standard deviation is 1.26. I give you 5 minutes. Try to do exercise in class 1. or n is 10, x is 3, your p is 0.3, your q should be 0.7, 3 here, 7 here, you should get 0.2668. Five is here, and another 5 is here. You should get 0.1029. Eight is here. Zero point 0014. This is the answer you should get. We go for exercise in class 2. Going for next page. A sign on the gas pump of a chain of gasoline station encourage customers to have their oil checked with the claim that 1 out of 4 cars need to have oil added. If this is true, what is the probability of the following event? 1 out of the next 4 cars needs oil. X, the variable here is number of cars need to have oil added. What is the probability that a car need to add oil? 1 out of 4. 1 out of 4, I can write this 0.25. A. one out of the next 4 cars. One out of the next 4 cars needs oil. Our n here is 4. Out of 4 car, 1 need to add oil. The probability of 1 car need to add oil is 0.25, 0.75. This is 1, this is 3. Answer is 0.4219. Two out of the next 8 cars need oil, and it's 8 out of 8. 2 cars need oil. For Cn is 12. 3 car needs oil. Exercise in class 3. Read that. Of course, if you want to write this in binomial statement, you can write it like this, but it is not compulsory. You can write, or you don't want to write also, no problem. This one would be 0.25. This one would be 8, 0.25, and this one would be 1. This statement you can write, or you don't want to write also, no problem. Okay. exercise in class 3. I'm going for new page. A certain type of tomato seed germinates 90% of the time. A backyard farmer planted 25 seeds, n equal to 25, p equal to 0.9. What is the probability that exactly 20 germinate? Out of 25, 20 germinate. Twenty or more. It starts from 20, 21, 22, 23, 24, 25. If you change that all this into the binomial formula and compute, you should get this answer. You can try now. For C, Px is 24 or fewer. This part you don't need to start with 0, 1, 2, 3 until 24. It will be very tedious. You can do like this: 1 minus and if you do this, your answer should be 9282. For D, what is the expected number of seeds that germinate? Expected number is equal to mean. So our mean is NP. So with this we have finished regarding the binomial thing. Of course there is tutorial, later I will upload that. Now we are going for the second type of discrete distribution, which is Poisson. Is going to be exactly the same thing almost as how we have formula for binomial, we do have formula for Poisson. It's just the conditions now a little bit different. Okay. For Poisson, if you look at the properties of Poisson, the number of successes that occur in a period of time or interval of space. Before this, discrete, there's no bound, okay, there's no limit, there's no condition telling that the outcome or the trials must happen in between this and that. There's no condition. Now here we have a condition or limit or a kind of bound. For example, you can see here the number of calls receiving during a given period of time. The given period of time is the limit, the bound. The number of bacteria per small volume of fluid is the bound. The number of customers' arrivals during a given minute is a bound. The number of machine breakdown during a given day. So all this, it must happen in a span of time, in a given space, and then it is a Poisson distribution. The formula is given here. Of course, if I explain the formula, you guys won't like it. Let us go straight away to the what do you call example. If you notice in the discrete, the input is n and p. Of course, q you can find if you know what is p. What is the q here? 1 minus 0. So if you have n and p, you can find the other input. So the major thing is n and p. For Poisson, they will give you a mean of success in the interval and number of success, of course, we have found. The only input in Poisson is mean. The two input in this binomial is n and p. Okay, you have to understand that. Look at this example. Let me write the formula is easy for me to compute later. Exponent, sorry, Euler number, E, Euler number, okay, this is the formula. Statistics instructor has observed that the number of typographical error in new edition of textbook varies considerably from book to book. After some analysis, he concludes that the number of errors is Poisson distribution with a mean of 1.5 per 100 pages. The instructor randomly select 100 pages of a new book. What is the probability that there are no typographical error? Variable is the number of typo in 100 pages. If you want to write this, you know the binomial, you have seen this binomial and p, isn't it? Now for Poisson also we can write it like this. For Poisson you just write the mean. Remember, this 1.5 this 1.5 is actually the mean of 1.5 for 100 pages. Okay, so this is the condition, only in 100 pages. For 100 pages the mean is 1.5. If the pages increase or decrease, the mean also we have to adjust, decrease and increase. So for the time being we leave it like this. What is the probability that there are no typographical error? The number of typo in 100 pages, 0, no typographical error. So if you follow the formula E, the mean is 1.5, 0, 0 factorial. If you compute this, you should get 2231. Suppose that the instructor has just received a copy of a new statistics books. He noticed that there are 400 pages. So no more 100 now, it's 400 pages. What is the probability that there are no typos? Okay. So now if you notice from the previous question, mean is 150, mean is 1.5 for 100 pages. For 400 pages, what is the changes from how you get 400 from 100? You times 4, isn't it? You times 4. How I get 4? 400 divided by 100. And times 4. Same thing for the new mean. I times 4. The scale must be same. If you times 4, what do you get? 6. New mean. The new mean is 6. Now based on this new mean, we are going to answer the next question. Remember, if 100, you have to use 1.5. If the space or if the condition is different, now the condition is in 400 pages, you have to change the mean accordingly. So the new mean is now 6. What is the probability that there are no typos? What is the probability that there are 5 or fewer typos? if you do this, your answer should be 0.446. Those who have done this, try exercise in class 1. I gave you 5 minutes. This is the answer for exercise in class 1. exercise in class 2. The number of accidents that occur at a busy intersection is Poisson distributed with the mean. Okay, mean is 3.5 per week. Per week, the condition is for 1 week the accident, the average accident is 3.5. Find the probability of the following events. No accident in 1 week. In 1 week, so we can use this mean. Before that, let me define what is X. You can write the statement like this. This is the answer. 5 or more accident in 1 week. Again in 1 week, so you can use the same mean. If you do this, you will get 2745. That is B. Going for next page. For C, find the probability of the events today, one accident today is one day, eh? So just now the mean was 1 week, 3.5 for 1 week is 7 days, eh? Now one accident today means one day. How 7 become 1? You have to multiply by this. I mean, you can divide by 7 if you want, or I can write it as multiply by 1/7. How I get this? Okay, find the scale first. So I times by 1/7. This one also times by 1/7. I will get 0.5. So my new mean is 0.5. Exercise in class 3, please read. You may try if you want, you may try. Exercise in class 3. the number of students who seek assistance with the statistic assignment is Poisson distributed with a mean of 2 per day. So X is number of students the mean is 2 with the mean of 2 per day. The condition is 1 day. In 1 day, two students will seek assistance for the statistic assignment. What is the probability that no student seek assistance tomorrow? Tomorrow is a 1 day. 1353. Find the probability that 10 students seek assistance in a week. So now they are asking the probability of 10 students seek assistance in a week, not in a day. So the mean must change. The mean of 2 is 1 day. Now in a week, 7 days. So what 2 times here? How 1 becomes 7? You multiply by 7. Okay, this one 7 divided by 1. That is a scale, so you multiply by 7, you get 14. This is my new mean. Now we can find the probability. That is the answer for exercise in class 3. Okay, maybe last part for this for today. The normal distribution I will start in a new class. Either I will do the video and upload, or maybe I will teach you in the class. Let's see how it goes. The last part for today is Poisson approximation to binomial distribution. So what is this? I'm going for new page. Actually the title is Approximation what we're going to learn in this section is we can use Poisson formula or Poisson distribution to solve binomial distribution. That's what we're going to see. We can use Poisson formula because Poisson, remember, Poisson is much more easier compared to binomial, because Poisson need only one parameter, one input or one parameter, which is the mean, whereas binomial need two parameter, which is your n and p. So Poisson is much more easier to solve than binomial. Therefore, we can also use Poisson formula to solve binomial, but there are some conditions. Okay, the condition is what are the conditions? The conditions is you can use Poisson to solve binomial if the n in binomial, okay, in the n in binomial is large, greater than or equal to 30, and p is small, less than 0.1. If you have this condition, then you can use binomial. Now let us try one example. A manufacturer of power lawn mowers buys engines in a lot of 10,000 from the supplier. She then equips each of the mowers produced by her plant with the engines. History shows that the probability of any one engine from the supplier defective is 0.001. In a shipment of 1000 engines, what is the probability that none is defective? First, I am going to solve this question by a binomial. the number of defective engine. The number of defective engine. If I use binomial, then the statement would be n is 1000, p is this one. What is the probability that none is defective? Out of 1000, you choose 0. Answer is 1. Now if I use Poisson, let us check whether can use Poisson or not. What is the condition? The condition is n must be greater or equal to 30. Is this n greater or equal to 30? Okay, this n is greater or equal to 30. Okay, first condition is fulfilled. Second condition is what? P must be less than 1. Look at this P is less than 1. Second condition also fulfilled. Therefore we can use Poisson. So how, before we use Poisson, we need to have the mean. The mean is NP from the binomial. This is equal to 1. So now we can use Poisson. If you compute this, the answer is almost the same. You can try. You see, same with this. Even though it is not exactly the same, it's almost the same. That's why we call this as approximation. Approximately same. In the exam, if it comes out, you don't need to show two-way. Okay, the question will tell you use Poisson, so you only have to use this one. You only use this one. If the question asks you find Poisson approximation to solve the question, means you only use Poisson. You don't need to show me binomial and Poisson both. If you see in the tutorial, the exam will clearly tell you by using Poisson distribution, then you use this method, Poisson. Now I suppose you guys have copied this. Let us start exercise in class 1. Please read. Diabetes is a chronic health condition where the body is unable to produce insulin. Medical Science Center report that the probability of a patient who suffer from diabetes is 0.002. will lead to blindness is 0.002. Assume that the distribution is not os is. Binomially distributed. If 2000 patients diagnosed with, here I am going to use Poisson distribution even though the question never tells, because we are in that section. Normally the question will tells you, if you see the tutorial later, the question will tell you. This is binomial distributed, yes. You can see the condition that this is n greater or equal to 30. In fact, it's better to n must be very large. Okay, is n greater or equal to 30, or you can see this n goes to infinity, very large. Another condition is n less than 0.1. Another way to see this, sorry, not n, p. Another way to see this, p go near to 0. So n, p must be very small, and n must be very large. Then you can use Poisson approximation. This fulfill the two conditions, therefore I can use Poisson approximation. So I will write here by Poisson approximation. The mean is, I need the mean to compute the Poisson. The mean is 4. So question A is x less than 3 until 2 . So I'm going to compute this. I'm going to factorize this. I will get 0.2381. The B I write here because B is quite easy. B is exactly 7 of the 2000 patient diagnosed will lead blindness. Here the answer is 0.0. This is the answer. Last question. Exercise in class 2. Number of seeds germinates. A is binomial with n10 and P is 0.75. You can see that this is n is not greater than 30 and is not big. P is greater than 0.1. P is quite big. So we cannot use the approximation for here. We have to use normal binomial, the normal equation. Question is, find the probability that less than 8 seed will germinate. Just give me some more time, a bit time. If you compute this, your answer should be this. This probability 0.575 is for germinator. We will do the last one, then we can finish the class. Okay, so I'm going for next page. Last one. If you read the question, find the probability that from random sample less than will not germinate. So X is now different number of seeds will not germinate, binomially distributed by 80, and this one is will not germinate, not germinate. In the question they will give you the probability of germinate. Will not germinate is 1 minus germinate. So if you can see here, this is, and this one is less than 0.1. We can use binomial, we can use Poisson. By Poisson approximation, .8. So the probability of X less than 5 is equal to, use Poisson, 'If you compute this, you will get this one. Okay, so with that, that's all for today. I'll continue in the next class. Next class may be in the class with you, or I may use I may upload the video for the normal distribution. So I will continue the normal distribution in the next class. Hopefully we can finish faster chapter 3 and can move on to chapter 4. Regarding the, as I told you, regarding the test and quiz, I will upload in the group. So thank you very much. That's all for today. Those who want to copy can copy first. Those who have copied, I'll see you guys next week. Thank you. Bye.